Hello and welcome back to the TAP-D demo series. I'm Hannah with Lightning Labs, and this is a series of videos where we walk through and generally demonstrate various different topics, particularly in this series, various different topics discussing Taproot assets. This video is going to be a little bit different in the sense that we're not actually demoing using the software here. In this video, we're doing a little bit more conceptual stuff, but I wanted to have a particular video that was dedicated to walking through the concept of how Taproot Assets is embedded in a Bitcoin transaction, how these assets, how we create this data structure, why we create it this particular way, and then how that actually gets into the Bitcoin blockchain. So what we're going to be discussing here is a Sparse Merkle Sum Tree. We're going to talk about, our goal is to understand, right, how Taproot asset data is stored and the data structure used and why we're doing it this particular way and what those benefits are. So we'll talk about this particular Merkle tree structure and then how that gets embedded into a Bitcoin transaction. So we're going to use the example here of just me imagining that I'm minting some assets. I'm minting some beef bucks, right? And we'll walk through what our Taproot asset daemon is doing in that process, what our TAP-D node is doing for us and the data structure that it's creating. All right, so when I mint these beef bucks, what I want to do is I want to be able to prove some things, right? If I want to mint this asset and then I want to send it to others, I need to be able to prove that I do indeed own the asset. I need to prove that I haven't been inflating this asset. And then when I transfer it, when I send some off to Bob, I need to be able to prove to Bob that I no longer own that asset if I have sent it all to him. All right, so what we're going to do is talk through this data structure that we're using, this Sparse Merkle Sum Tree, and we're going to go through each part of that. We're going to start first talking about the sparse aspect of that, and then move along to talking about the sum aspect of that. Then we'll put it all together. So let's look at this picture here, right? And these pictures I'm going to show you, this one is a bit more technically correct, but none of these are strictly technically correct because visualizing these data structures is very hard to fit it into a graphic, right? Some of these trees are just massive, right? And so we kind of sum them down into these visualizations that are not strictly technically correct, but hopefully very helpful for us, right? So we're going to look at this one, but we're going to imagine here, first it's important to note that when we're talking about these Merkle trees, it's not just one Merkle tree. I like to think of it as sort of a Merkle forest with different layers to it. But let's focus in for a minute on this sort of bottom layer here, where we specifically add the data on our assets, right? So if I want to mint beef bucks and I want this to be a fungible asset, maybe I have some metadata I want to include, whatever the case may be, I'm going to take all that data, I'm going to give it to TAP-D, and then TAP-D is going to put it in the leaf right at the bottom of this asset tree right here. This is where it's going to live. All right, so TAP-D puts that data here, and the first problem we want to solve for is that I need to provide a proof to Bob that I did indeed mint this asset and I have this asset, right? So what I'm going to do is what TAP-D does is take this data and then take this epic Merkle tree, right? But they call it a Sparse Merkle tree because I have this massive Merkle tree, but I have just one leaf in that tree that currently has any data in it. And that TAP-D is going to create an asset ID. And what's interesting about this asset ID is the binary representation of that asset ID is actually a map that brings you from this root hash, turning left or right for ones or zeros, all the way down to this particular leaf, right? And I'll show you an animation of that in a second. But the idea being is that that asset ID also is a map to where it is in the tree. And this allows us to provide proofs. If that proof includes the asset ID, then we know exactly what that proof looks like and what part of that tree that proof is going to point to. So if we decide that, okay, every leaf on this tree has a different asset ID and this corresponds to its position in the tree, then we can provide a proof that shows that we do or do not own this asset. That asset is or is not included in this tree. All right, so let's have a look at an animation that hopefully helps you visualize what's going on here. All right, our sparse animation. Let's have a look at this. Here's our tree, and then we can see if we have an asset ID that sort of functions as a map, right? 1 perhaps means go right, and 0 means go left, etc. And that brings you right down to that particular leaf where that asset lives. So look at that one more time. Go this way and that way and the other way. Oh, and I didn't pause it at the right moment, but there we go. Cool. So hopefully that helps you visualize how we can have a particular asset and we have to have it at a certain part of a certain tree, and then we can provide a proof that shows that it is or is not in that tree, right? So that solves the problem of how do we prove we have the asset and how do we prove to Bob that we no longer have the asset when we send it along to him. But of course, that's only half the battle, because we want to get to that sum part, because we also need to prove to Bob that we have not inflated our asset, right? So if we go back to our picture here, right, I have this asset living down here, and let's say I have 100 beef bucks, right? I have these 100 beef bucks. I need to prove to Bob that I do only have 100 beef bucks. And also, if I send him 50 beef bucks, I now no longer have 100, I only have 50, right? We need to be able to provide proofs for this. So we add that sum part into this tree. So down here, this asset leaf that holds my beef bucks data is going to have with it a numerical value. In this case, 100, because I admitted 100 beef bucks. And that's going to be transferred up all the way to the top of this tree. And we'll call it sum, right? Because we can imagine here, if over on asset leaf X, I've also minted 100 Alice bucks. As we go up this tree, so this node on the tree then has the value, the numeric value of 100. So is it here, here, here as well. Also along this path, we also have the numeric value of 100, each representing these assets. And then at the top, we would have 200, right? And so if any of these values, right, so if I then send 100 or 50 of my beef bucks off to Bob, then in my new Merkle tree, the value here is 50, right? And up at the top, when we get to the top, this root hash, that value is, that change in what I have down this asset is reflected up at the top and reflected in all of these proofs, right? So if I go around lying about what's here and don't structure my Merkle tree properly, I can't provide a proof. I've essentially burnt my own assets, right? So what we want to do now is just have a look at an animation that, again, just helps you visualize what's happening here. So this is our Merkle Sum Tree animation. So we can see the value at the root hash. If this value changes here, that changes all the way up to the top. Let's look at that one more time. When the value of this leaf changes, that's going to wind up getting reflected all the way up at the top. Cool. So hopefully that helps you visualize what's happening in this data structure and why we've created this data structure in this fashion, so we can provide these proofs to prove that we do or do not own something and we are not inflating it. Awesome. So if you're still with me, we're going to touch on a couple more things. I want to note that there are, like I talked about earlier, there's layers of these trees, right? So I'm assuming here that you already have some familiarity with Taproot things in Bitcoin, right? So we can look at this again, simplified, made nice and pretty, so it's easy for us to imagine. But this tree down here is the asset level, and this tree up here is the group level, and then this tree here is our standard Bitcoin Taproot tree. Right. Let's talk for a moment about the group level. If I'm minting these beef bucks and I want to continue to mint these beef bucks, I want it to be a fungible asset, maybe something like a stable coin. I might want to mint another round or burn some, whatever the case may be. But I want each round of beef bucks to be fungible with one another. That's where this level right here is really important. So all the assets coming off of this level all are in the same group and are all fungible with one another. So that's really important. Another thing I'll note here, that because of this structure, the sort of layers, that we can require signatures at various different spots, right, from different private keys along the way. Basically, we can lock things at various different points in this structure. So this provides for a lot of flexibility in use cases and some security. So that's cool. Now, if we have all of this, right, if you're still with me all the way to this point, we might be saying, okay, cool, I understand this structure. How do we get that into a Bitcoin transaction? Well, non-technically speaking, what we do is just sum all this data up and then shove it into a Bitcoin address. But a little bit more technically, hopefully you're familiar with tap tweak. That's some cool math. But basically what we do is we sum this all up to a root hash, and then we use some fancy math to add that all to a Bitcoin address, right? And this is pretty standard Bitcoin Taproot stuff. This is part of it, but basically tap tweak is the one-word answer to how we get all of this data into a Bitcoin transaction. But I'll get you one more pretty picture, which might sort of help you visualize that. A lot of people like to just imagine it as Taproot Assets live in a Bitcoin UTXO, which I think is a pretty fair and very helpful way to visualize it. So if I'm doing the minting here, I might have a couple of inputs where I have to create a transaction to mint this on the Bitcoin blockchain. So I've got some inputs into this transaction, but when I am in the process of creating these assets, right, I have TapD, which is communicating with LND, which is communicating with perhaps Bitcoin D, right, my Bitcoin backend. And in this whole process, I'm taking all of this data structure and basically embedding it in this address where I will use to send funds to in my output. Right, so I have these inputs, and then in this output, I've shoved all of this data into a Bitcoin address. And so this is where my Merkle forest lives, in this Bitcoin Taproot UTXO. So let's summarize that. What we've talked about here is the data structure used in Taproot Assets to create these assets and then mint them on the Bitcoin blockchain. So we talked about Merkle Sum, Sparse Merkle Trees, and then we've talked about using the different layers that are used there in that data structure, and then how we use tap tweak to embed this in the Bitcoin blockchain. If you have any further questions on this, please don't forget to check out the docs at docs.lightning.engineering, and I'll see you next time.